Hi there, Chem Squad. So last time we looked at concentration, temperature, and surface area as factors for affecting rates of reactions. Um, right now, there are about three others that we haven't looked at yet. And number four is basically pressure, volume. Now we say pressure, volume because these two are related to each other. Okay. Um, Pressure and volume are inversely related. Meaning that if pressure increases, volume has to decrease. If volume decreases, pressure increases. Okay. This factor does have a condition. Okay. It works best for gases and aqueous solutions. So it affects gases and aqueous solutions. Oops. More so than solids and liquids. Okay. And that's because gases and aqueous solutions, their molecules are already spread apart. Okay, so any tiny pressure change or volume change typically affects these chemicals much more so than the already compact solids and liquids. So if we look at an example here, some of you might remember this from grade 11. If we had a little container and we put a piston, or essentially a lid, on top of it, okay, and if we had some gases that are already inside, so let's put some gas molecules in here. Okay, so let's say this is gas 1, okay, or reactant number 1, and we'll pick a different color for gas number 2. Okay. They don't have to be the same amount at the beginning here. Okay, it really doesn't matter. So let's switch back. Okay, so sorry, this is gas number 2, or reactant number 2. So right now we have a little bit of pressure, but a lot of volume. Okay, so if this is our starting point, if we change one of the variables, okay, let's say we increase pressure. Don't know why that's there, but let's say we increase pressure. So we're going to increase pressure. Then our little diagram here changes like this. So we're going to increase pressure. So there's more pressure being placed on the piston or lid. Okay. So here's my pressure, it's much bigger. But notice that the volume has decreased. Okay. So whenever you increase pressure, volume decreases. And because that volume decreases, the number of particles inside gets squeezed together. Okay, there's less space. So what we see now is molecules are closer to each other. They have more opportunity to collide with each other. Okay, so more collisions will occur. So more collisions that happen, the faster the rate. So in the end, we can kind of summarize it like this. If you increase the pressure, you increase the rate of reaction. Okay, or you can look at it as in terms of volume. If you decrease volume, you will also increase the rate. Okay, so the opposite has to be true too. If you decrease pressure, you decrease rate. So decrease pressure, decrease rate. And again, if you're looking from volume perspective, if you increase the volume, you decrease the rate. Okay, so they're inversely proportional to each other. Now, the reason why this affects gases much more so than solids and liquids, I can kind of show you here because I have a little bit of extra time. If we take the same container, okay, and this time we put in a cube, okay. It doesn't matter if we increase the volume, decrease the volume, increase pressure, decrease pressure, okay, because this is what happens. That cube, with all its particles, are still in the same place. So even though we've increased pressure or decreased volume, nothing has affected the solid, right? So no effect on the solid. Okay. You could have more solids here. Right? As long as the change in pressure is just slight, it's not really going to affect solids or liquids. Okay, so no effect on solids / liquids. Okay, it only affects gases in aqueous solution, okay, in a much greater sense. Now, obviously, if we totally increase the pressure to the point where it crushes or compacts the solids, okay, even then we start seeing a little bit of change, but it's still not a great enough change, okay, in order to increase rate. I mean, by the time you do that, you're basically increasing surface area. So surface area has a much more bigger role in this case than pressure volume would on a solid and liquid. All right, so there's, again, 3 more factors left, but that will have to wait till the next video.